Question 8 is from the November 2009 A-Levels. It's a typical question where we are asked to find the roots of a complex number. So we have to rewrite the complex number in the exponential form. And in order to obtain 7 different roots, we add multiples of 2 pi. So k times 2 pi, or 2k pi, to the argument. Let's try to express the argument as a fraction. And now we can take the 7th root. Applying laws of indices, what we are doing is really dividing each of the powers by 7. Of course, it's a good thing to indicate that k is an integer, any integer, earlier. Now, in order to obtain 7 different roots, we are going to let k take on 7 different integer values. It could be -3, -2, and so on, all the way to 3. So we count, there are 7 different values of k. So your z could be, if we sub in k equal to -3, we will obtain -23 pi over 28 for the first argument. Next, we sub in k equal to -2, to obtain the next root. And so on. Now we are required to represent these roots on an Argand diagram. So how do we do that? First of all, notice all the roots have the same modulus, which means they have the same distance from the origin. That will give us a circle centered at the origin with radius 2 to the power of 1 over 14. Now, what about the roots? If you look at the arguments of all the roots, notice that there's a pattern to them. They will be evenly spaced out on the circle. So, let's start with pi over 8. Using your protractor, you can measure off pi over 8. 9 pi over 8, 17 pi over 8, and so on, until we complete one round around the circle. So here you can see I've completed my round around the circle, and all 7 roots are equally spaced out. Let us indicate the radius of the circle as well. 2 to the power of 1 over 14. Now, if we go on to part 3, we see there are 2 special points called Z1 and Z2. And what does this inequality tell us about Z1 and Z2? Yes, they are in the first quadrant. An argument of Z1 is less than argument of Z2. So this must be Z1 and Z2 respectively. Look at the next equation. What kind of locus does it remind us of? Yes, it is a perpendicular bisector between Z1 and Z2. So now, if I look at Z1 and Z2, join them, mark out the midpoint, and draw a perpendicular line through it. The question is asking us to show that this perpendicular bisector passes through the origin. How can we show this without doing any calculation? Well, it comes down to what is our understanding of a perpendicular bisector. A perpendicular bisector between Z1 and Z2 is really the set of all points that are equidistant from Z1 and Z2. So the million-dollar question is OZ1 equal to OZ2? Because if they are, then O lies on the perpendicular bisector. Think about it. OZ1 and OZ2 are indeed equal because they are both the radii of the circle. They are both equal to 2 to the power of 1 over 14. Okay, I just indicated the equation of this locus. Therefore, OZ1 equal to OZ2, so O lies on this perpendicular bisector. In other words, the bisector passes through the origin. What is the equation of the line in the form y equal to mx plus c? Clearly, c equal to 0 because it passes through the origin, while m is related to the angle theta that it makes with the horizontal. M equal to tangent theta in general. How do we find theta? You notice that it is halfway between the argument of Z1 and the argument of Z2. From our list of roots, the two smallest positive arguments are pi over 8 and 9 pi over 8. Theta is halfway in between these two angles. Therefore, theta is the mean of the two angles. And therefore, we have y equal to tangent 5 pi over 8 x.